Hello students, in the last video you got an introduction to algebra of sets and learnt about the union of sets, verifying some properties of union of sets along with Venn diagrams. Today we will discuss about intersection and difference of sets. Before we begin with the topic, look at the animation and observe what he is doing. Take your time. Watch it carefully. What do you observe? He is selecting common items. So, that is our today's topic, intersection of sets. Intersection of two sets A and B is a set of elements that belongs to both A and B, that is, the common elements of A and B. It is denoted by A intersection B. Symbolically, A intersection B is equal to X such that X belongs to A and X belongs to B. Red part in diagram describes the intersection of A and B. For example, if set A has 1, 2, 7 and 9, set B has 3, 4, 5 and 6. And set C has 3, 4, 5, 6 and 7 as elements. Then B intersection C is 3, 4, 5 and 6. And also A intersection B has no elements, that is, A intersection B is a null set. Which give us a new term in sets, disjoint sets. If there is no common element between A and B, then they are called disjoint sets. Venn diagram is shown. Circles are not overlapping as there is no common item in two sets. Next is difference of sets. The difference of two sets A and B is the set of elements of A that are not in B. It is denoted by A minus B. So, difference of A and B is X such that X belongs to A and X does not belongs to B. Here, the Venn diagram shows A minus B shaded in pink and the part shaded in red shows B minus A. For example, if A is 1, 2, 3, 4 and 5, B is 3 and 5 and C is 2 and 4, then A minus B is 1, 2 and 4 and B minus C has no elements, so a null set. We can also say that B and C are disjoint sets. Now move to complement of a set. If a set A be a subset of the universal set U, then the complement of set A is a set of all elements of U that are not in A. The complement of set A is denoted by A dash. It can be written as the complement of set A is X such that X belongs to universal set U and X does not belongs to A. For example, look at the picture. Two parts of the pen are complement of each other. The Venn diagram will be like this. Shaded part represents the complement of the set A. If U is a general set with elements 0, 1, 2, 3, 4, 5, 6 and 7 and A contains 0, 2, 4 and 6, then complement of A is 1, 3, 5 and 7. Here is the Venn diagram. So, we can say that complement of universal set is a null set. Venn diagram make it more clear. Also, complement of null set is universal set. For example, let U be equal to 2, 4, 6, 8 and 10 and A be equal to a null set. Then, complement of A is 2, 4, 6, 8 and 10, which is a universal set. So, complement of null set is universal set. Further, complement of a set is set itself. Let U is equal to 2, 4, 6, 8 and 10 and A is equal to 4 and 6. Then complement of A is 2, 8 and 10. Complement of A is 4 and 6. Complement of A is equal to complement of A. Let's have an example of Venn diagram to verify the distributive law. That is, union of A with intersection of B and C is equal to intersection of union of A and B and union of A and C. First part in the diagram represents the set A. In second part, intersection of B and C is shown. If we take the union of both parts, it will give us union of A with intersection of B and C. In next diagram, first part shows union of A and B, while the second part shows the union of A and C. The intersection of both parts, that is, intersection of union of A and B and union of A and C, is shown in the third part of the diagram. So, from the diagram, it is clear that union of A with intersection of B and C is equal to intersection of union of A and B and union of A and C. So last but not the least, we can use Venn diagram in different ways. We can prove the important properties of sets, that is, reflective property, commutative property, associative property, distributive property and identity property. Thank you.